So hello. Just a little bit of background about me and my current work. So the reason why this talk happened is because I am currently working on a project called Socorro. It is kind of a ETL plus reporting tool for Firefox crashes. So anytime Firefox crashes, you can send me a personal note and it'll go into the database that I support at Mozilla. And I'm sure that Firefox crashes very infrequently for all of you, so I won't be hearing from many of you. But you can go and see our work on crashstats.mozilla.com, and the repo for all of the code that we write is available on GitHub as well, and you can check that out. And all the migrations that I have been writing with Alembic for the past, I guess it's been 8 months now, they're also available in that repo, so you also get to see the evolution of my ideas about how this should work. I also want to say thank you to Mike Bayer and also apologize for any errors that I make. They're definitely mine, not his. But Alembic is a great tool and definitely owe this talk to him. So for those of you who were here just a few minutes ago, I was mentioning that about half of this talk is about schema management and the other half of it is about Alembic specifically. And the reason why I titled this Sane Schema Management is because I think that there's a lot of problems with the way that we tend to manage schemas today. And my idea of a sane environment for this is one where we have a controlled and repeatable way to change schemas while we're working with developers and operations. And that's surprisingly difficult to do. And so what's Alembic, for those of you that don't know? It is a schema migration tool that integrates with SQL Alchemy, and I really like it a lot. So some of my assumptions about the environment, so this is, I'm basically describing what my environment is and kind of where I'm coming from in this. For us, schema migrations are frequent. Weekly or more often, I am changing my schema. That includes adding columns, removing columns, adding indexes, adding stored procedures, just anything involving the schema. That happens fairly frequently for us. And I want our schema migrations to be as automated as possible. They're not fully automated. There's always things, right? There's always things that happen with schema migrations where you can't make it fully automated, but I would like it to be as automated as possible, and especially to be able to run without me being present. Our stage environment is as close to our production environment as time and budget allows. So I actually have a copy of our 1.5 terabyte production database in our staging environment. And that really does enable a lot of the automation work that I do, because we catch any mistakes that I made in these migrations in stage before it goes into prod. And I think that that is pretty essential to automating this stuff, having a place where your mistakes get caught. And finally, I think that when you're writing migrations, writing a little bit of code in another language is okay. And especially when you're working with developers, I think that it's pretty critical, because often the developers, for whatever reason, often are very irrational. They have these irrational fears about reviewing SQL. I don't know, how many of you here actually have developers who review your SQL? No one. Oh, one. Yeah. I had a really hard time getting people to review my SQL, and especially had a hard time getting them to review Bash that was then executing SQL. And, you know, rightly so, it's terrifying stuff. But when I started using a migration system in Python, the Python developers were much less opposed to it. And now every migration that I do is reviewed by a developer. So I'm going to say this again at the end, but I just want to state state some basic things that I believe. No tool is perfect. I really believe that DBAs should be driving the migration tool choice. And I think it's really important for DBAs to work with developers in choosing a tool that the developers like, or at least don't totally hate. All right, so this has about 5 parts plus this prelude about some of my special DBA problems. I'm going to talk about why we should work with developers on the migrations, a little more detail about that, picking the right migration tool, how to do that, some of the questions you should ask, and some of the features you should be looking for. Part 3 is actually using Alembic, how I use Alembic. And then 4 is the 3 kind of big lessons that I've learned in my implementation so far. And the last part are some things that Alembic could learn, some things that I wish that it did automatically that, maybe some of you here will end up writing some code to do that. All right, so let's start out with the awesome failure stories. Migrations are really hard, they're really messy. Who here has ever had a migration go wrong? Yeah, that's right. Okay, so, and they're really necessary, like we have to do them. We can't just create a schema and have it exist without changing. So this is terrible. This is some terrible stuff here. I'll deliver the punchline here. You can see that without in quotes right there. Basically what happened was I had a series of partitions, quite a few partitions, that ended up getting a check constraint applied to them that was without time zone when it should have been with time zone. Oops. Yeah, big oops. So anyway, so this was some code that I shared with some friends of mine as I was like trying to figure out, how I was going to fix this. And anybody want to guess what some of the problems are with changing check constraints? Keyword. Sorry, go ahead. Yell out, shout it out. Well, not you in the back there, but you already know. Some people, anyone? Come on. What did you say? Yeah, locks, right? And specifically deadlocks. It's real sweet. Fortunately, I have an application that's actually pretty tolerant of deadlocking failure, but it's still unpleasant and causes all kinds of things, all kinds of alarms to go off when it happens. So anyway, so I had to change over 1,000 check constraints in this 1.5 terabyte database. And if you go to that tiny URL, you'll see the migration that I ultimately ended up using to make this change happen. And which is kind of fun to see how messy it was and is. So some of the things that really sucked about this, this wasn't the first time that we'd seen this error creep in, which is really sad. We actually have some bugs, so I work for Mozilla. Almost all of our work is done publicly, so you can see these bugs in bugzilla.mozilla.org from 2012 where people were seeing some of these check constraints gone wrong. And we thought we'd fixed it back in November or December, but it snuck back in, the error snuck back into some user-defined functions that implemented the check constraints sometime between January and April. Unfortunately, there was no useful audit trail. And as I was looking at the different partitions that were affected, some were and some weren't. And the error dated back to 2010. So this was a pretty clear wake-up call that we kind of needed to examine our processes and make this better so it wasn't going to happen again. So I looked into the face of the evil, and this is the diagram that came out. It kind of reminded me of this. But anyway, so you can see here, there's some code change. The developer's like, hey, we need to change the schema. And you're like, all right, cool. Like, I'll make some SQL for that change. I'll test it, on my laptop or whatever. And then I copy and edit some template files, in some bash scripts. And then, oh man, I gotta recreate the old schema. All right, okay, so I did that. Now I gotta run this upgrade.sh on the old schema, and then of course something fails. So I update, my bash script, and then recreate, I go in this little loop over there, tight little loop, it's really great. And then eventually, once I get out of that loop, I go all the way over and I commit this migration to the repo, often without any code review, because like I said, nobody wanted to review these bash scripts. I've got a little loop, I'll talk about that in a minute, but we'll skip that for now. And now we move on to testing in stage, so we try to deploy it, and if it fails, we've got to go back to our testing loop. And then here's a really interesting thing. How do you get a valid ending schema back into your repo? Well, for us, we had to do a PG dump from stage, right? There's a lot of problems with doing this. But anyway, so we dump it from stage, and then I would very carefully edit out anything that was in that schema that was going to break our test suite. And then I would test that locally and commit a new revision of the schema to the repo, right? This seems so awful, but it was mostly working, except for, the aforementioned, this happened. But, it was sort of working. But anyway, so these are the kinds of things that when I ask people about their migration system, this is a lot of times what they eventually confess to me they are doing. And this is what it's like now. Just for a comparison, there's a lot more boxes on that one, a lot fewer on this one. There's still some elements that are the same, right? We're still running these tests on stage, and if our migration fails in some way on stage, we do go back to that testing loop. But we're not dumping from stage anymore, which is really nice. We've separated out the actual schema dumps from what we're storing in our repo, and it is such a huge improvement. So anyway, big changes. We have a code change. Developers, a lot of times I'm working with the developers on these schema changes. We create the old schema. We create an Alembic revision, which is just a command that we run. We edit those revisions a bit and test them. And after the update revision step, I actually get code review from my developers on what I'm doing. We run things also in Jenkins. So there's a few steps in here that I left out that are, about our staging and test environment. But that's going on in the background. And then finally, we commit it to the repo. We run it on stage. And hopefully, at that point, we have success. So that's our process now. So just to sum up, what's really awesome about this now is we test the stuff in stage with these migrations. Experimentation here often reveals, or in this specific case, the experimentation revealed which partitions could be modified without excessive deadlocking. So I wasn't crashing my app. And I was able to roll out my check constraint change during normal business hours with our just regular release schedule, which is every Wednesday around 11 a.m. And it is so awesome to be able to do that. And just to put that process with Alembic into words, this is pretty much what I do every time. I have a blog post that I point my developers at when they're figuring this out for the first time, and this is what they do. They make changes to our model.py. Or maybe they edit some raw SQL files. They run Alembic. They edit the output revision file for whatever they need to change. They commit those changes, and then we run the migration in our staging environment after our continuous integration loop finishes and the code is automatically deployed. And we're actually now probably, when I get back on Thursday, we're going to turn this on. We're going to stop manually running migrations, and we're just going to let the continuous integration system take care of it for us, which is a really exciting step. So the problems that Alembic solved, it gave us some really easy to deploy migrations that the developers were going to use. I embed raw SQL in my migrations, which most people end up doing, and I also issue multi-commit changes, which I had to do for these check constraint changes. Otherwise, I was going to use up all the memory on the system. And Alembic by default includes downgrade function, which I force people to implement. It enabled database change discipline, code review discipline, and it decoupled our schema revisions from our releases and also from our branch commit order. Because we use feature branches for everything and are merging them constantly. And it was really nice to be able to just stop worrying about which release number was associated with a particular schema version. Some other things that happened for our specific code base, I removed about 100,000 lines of code, which is kind of insane, all related to the schema that we were committing. We have no more post-deploy schema check-ins. It really further enabled a tested automated stage environment, and we separated the schema definition from our version-specific configuration, which when we were upgrading from 9.0 to 9.2 was a huge problem because I had all these extensions that had kind of polluted the schema, and it had to be hand-edited every time we were doing an upgrade, and it was very, very frustrating. So it's really nice to not have to worry about that anymore. So in the end, this is me. I was so happy, like a cat in a box. Anyway, a lot of my problems were solved, and I was extremely happy to start using this system. So when I brought up the thing that I brought up on Twitter was using ORMs. And I started feeling a little bit like, when I saw this picture, I just like totally, it's like of a woman who's sort of like preaching on a corner, like in Hollywood. And I felt a little bit like that person. Like I was really like firmly believing and really passionate about like what I was doing, but a lot of people were like, you are insane and I don't know why you're trying to get us to do this. So anyway, so please bear with me as I'm kind of talking about some of the stuff. So I'm gonna say something really uncontroversial first, which is that schemas change, right? Yes, we're all cool with that. And also developers really find the process of schema change to be very frustrating. I don't think there's anything, I don't know, does anybody find that controversial? No, I just see frustration face all the time when I'm having conference calls with my buddies. And schemas, what they're really good for, they're good for signaling intent, right? Like what we wished that the queries were that were run against the data. They communicate an ideal state of that data. And they are extremely customizable in Postgres, which is a strength and occasionally a weakness. And what they're not really great for is rapid iteration, documenting the evolution of a design, because you only are seeing where you're at right now, not all of the changes that led up to it. Major changes to big data are always super problematic. I say as a person who maintains a 1.5 terabyte Postgres database, which by far is not, the largest data set that people I know are maintaining, but it's still pretty big. And any kind of experimentation that involves having lots of different kinds of schemas available, it's just not great. And how I've come to think of this is through this poor cat on a leash. Database changes really resist change, and there's actually some really good reasons for it. I mean, I think that cats really should walk on leashes, but databases are different. And they resist these changes because they exist often at the center of lots of different systems. And stability is a core competency. Like you don't want your database changing all the time and crashing, that sucks. And oftentimes the schema is this only API between lots of different components. And because of that, you end up being responsible for lots of things that you really probably shouldn't have been your responsibility, but you're working on the database, so they are. So how do we typically make changes to schemas? Well, because of that resistance, most people often treat schema change as sort of like a one-off process. Like, we're not going to do this very often, so let's just wing it. And so I came up with this to sort of describe the evolution of schema change. I don't know if you can read all of that, but my favorite is the /ef. Do you know about /ef? Yeah. Okay, so in the PSQL command line, this is super awesome. Probably not on prod, but whatever. So like you can go in there and you just do like /ef and then a function name, and it pulls up the whole function, and you can just like freaking edit it right there. Like that is so great, right? But maybe not on production. People do though, whatever. Another thing that I've seen people do accidentally is have auto commit on in PSQL and make some interactive changes in prod, and oops, just dropped a table. Dang, can't uncommit that. And then once you kind of make a few mistakes there, you'll end up with SQL files or SQL files in bash. It's, acceptable, that happens. And that's what I had when I started working on Socorro. And then after that, people kind of work their way into revision control, and they figure out some systems. And then I think the holy grail is getting to this point where we have tests in complete stage environments. I know that that's hard. Funding may not be available. Or the environment that you're in may be just so far from that you can't do that. But that's kind of the spectrum that I tend to see. And getting back to this, why should we be working on migrations with developers? Well, the DBAs are often responsible for picking up the pieces from poorly executed schema change plans. This happens all the time. And if we were really to engage with developers from the beginning, I think that we'd have a lot better relationships. And I think that we would help educate developers about why they should be concerned about this, how the change is going to be executed from the beginning, what the implications are, and they should be part of that process as well. And the way that I sort of frame this to my developers is, how are we safely going to do this so that we don't lose any data? so that I'm not waking you up at 1 in the morning because I'm mad because of some stupid change that you made, and so that we can do things like execute a check constraint change in the middle of the day without taking down our application. And it comes down to two things. And the reason why I go through all this is because I think another job that you often end up being in the position of is justifying why implementing more process, why adding another tool to your environment is so important, either to your management or to your team members. And I think going through this with people, if they're not already convinced, is a pretty effective way of getting it done. So anyway, so the process and the tooling are the ways that you get it done, both documenting your existing process and kind of seeing, you're here, you're going over here. And then the specific tool that you pick is going to have a huge impact on how this all goes down. And I really think the DBAs should be the ones to choose this stuff, because ultimately you're going to be held responsible for it. And I've started to really think about migration tools as configuration management tools, and really thinking of schema as configuration for data. And the reason why is because the migration tools communicate a change, they communicate process, and in the same way that a configuration management tool helps you have this controlled and repeatable way of changing your server environment, the migration tools do perform a very similar function inside the database. All right, so you're all sold, right? You're all gonna go out and choose your own adventure and find the right migration tool for you. So how do you go about picking one of these things? And I'm just going to describe the process that I went through. And for me, I mostly was choosing between South and Alembic here. I didn't actually end up using South because most of our application is not Django specific, but it was an option at one point. To do that. But anyway, so the questions that we as a group, so I worked on this with my team. I've got a team of about 10 people, all doing different, working on different aspects of our application. We asked, how often does your schema change? Can the migrations be run? This is from my perspective. Could the migrations be run without my intervention? Could we test these migrations before we ran it in production? Can the developers create a new schema without my help? And unfortunately, when we started this process, the answer was no. And how hard was it to get from the old schema to the new one with the tool? And then finally, are change rollbacks a standard use of the tool or a one-off? And I think that those are all really, really important questions to ask when you're sort of framing, implementing the system. And again, what does the actual migration system need to do? It needs to communicate change. It needs to apply the changes in the right order. It needs to apply the change only once, which is a funny thing that some systems aren't capable of doing. It needs to use raw SQL where it's needed. When I'm making a check constraint change, I don't want to try to use the ORM to construct I don't know what to make that happen. It needs to provide just a single interface for the change, and it needs to be able to roll back gracefully. And Postgres is really great because we've got transactional DDL, so that's pretty straightforward how that works. And so here's the controversial thing that I'm going to say. I really think that you should use an ORM with the migration tool. And I have a really specific reason for this, and it's not to write queries. At least not selects. Before I implemented our migration system, we had 3 different ways of defining schema inside of our code base. We have quite a sprawling code base. I don't think that everybody ends up with this kind of a problem. We had a sprawling code base. Probably a third of it was deprecated, but the unit tests were still using all of this crazy stuff. And so we really needed to find a way to unify all of that, and the way that it happened was by using an ORM. And the primary driver for that was providing a single source of truth for the schema. And the second reason, which I should have put on here, was being able to have the developers view the schema in their language. I wasn't making them look at raw SQL to see what the schema was. They could just look at Python objects and understand what was going on. We ended up with reusable components so we could test just part of the schema instead of all of it at once. And we got the database version independence and the ORM itself that we chose had the ability to just hand it raw SQL, which is super important. Yeah, and I mean, this is important stuff, but not very important for what I'm saying right now. Yeah, and so what I ended up getting out of this relationship, this new relationship that I have with my developers around the schema, was I had a new way of thinking about how change was happening inside of our code base, particularly around the schema, and how difficult it had been before for them to implement those changes themselves. I developed quite a bit of compassion for how horrible ORMs can occasionally be, and not just from queries that people had pasted me, but from firsthand experience. And it really gave me a vocabulary for talking about code change around the database that I didn't really have before. I am a developer. I have been writing code since I graduated from college. But mostly, I'd worked on systems and systems integration, and also, on the back end of the database. So this is the first time that I was working with web application developers and trying to talk to web application developers about databases. It's a very different mindset. So anyway, which you all, I'm sure, came for, using Alembic. So I wrote this blog post. It's a practical guide to using Alembic, and it just goes through how my developers set up their environment. And so you can have a look at that if you want. It's like nice narrative style. And you'll see exactly how we currently use it. The Alembic docs are really great. You can, if you've never seen readthedocs.org before, this is what a lot of the Python projects use for their documentation. It uses a tool called Sphinx to generate, and it's pretty and great. And there's a few terms that you'll kind of need to get used to right off the bat. A revision is essentially a single migration. A down revision is the previous migration. An upgrade is how you apply a change. Downgrade is how you apply the downgrade function that's in that change. An offline mode, it has an offline mode, so you can actually emit full raw SQL instead of running the Python migration, if that's how you want to run things in your environment, which is really nice. So this is kind of how things go down, like on the command line. How many of you here have ever heard of virtualenv? Yeah, that's a lot of you. Okay, cool. So for those of you who have never seen virtualenv before, it's just a way of running Python modules in its own like self-contained environment. And it's a nice way of isolating your Python environment from your entire system configuration. So a lot of people will use virtualenvs when they're setting things up so they don't pollute the rest of your system Python environment. So this is how I usually start. I create a virtualenv. Each one of these lines is a separate command. I activate the virtualenv. I just use pip install Alembic, and it'll install Alembic and all the dependencies, and hopefully that works. And then on any modern Linux system, it definitely will work. Most Mac systems it will. Windows, don't know. And then you run Alembic init. Oftentimes what people will do is they will run Alembic init inside of their larger code base, and that's what we did. So now inside of the Socorro code, there's an Alembic directory, and it's got all that stuff in there. So when you do that, you get an alembic.ini. You need to edit that, edit some config, and then you can start running the individual commands for creating a revision, upgrading, downgrading. And it's pretty simple other than that. So I want to quickly go through, like, I don't know if any of you like wanted a demo or anything. Do you want to like see it run? Okay, I'll do that at the end. But yeah, those are the basic commands. It's really fairly simple. The tool itself is I'm grateful for its simplicity. So some of the stuff that you have to do right in the beginning. So let's say you take my advice and you use the ORM, you use SQL Alchemy, and you create a model. How do you make Alembic aware of that model? Well, the way that I did it was you edit the env.py and you just import your model into the system. For us, it's socorro.external Postgres, model.py or something like that. But you just import it in there, and then it's available to your migrations. Another thing that I've started doing recently is creating little helper functions for doing silly things like changing the ownership on a table. got sick of typing the whole thing out, so I've got a little helper function that does that. And another helper function that I have is for loading raw SQL, which I'm going to talk about in a minute. But anyway, you can also just, same strategy. Create a special library and then just import it into your env.py in your Alembic directory. Another thing that I do is that, so Alembic has this auto migration feature where it will look at your model and compare that to an existing database. And when it does that, if you've got a lot of partitions created in there, you have to tell Alembic to ignore those. So I've created a little, thing in here. All my partitions, have a date appended to them. So just ignore all of those tables, and also look in this special schema that we've got in here. And so you can just define this in the include symbol function, also in your env.py. So how do we manage user-defined functions? So this is actually a pretty hard problem to solve. It took a little while to come to what we eventually came to. So originally, like I said, we were just managing everything with bash and raw SQL. There was a schema.sql file that had our entire production database dumped in it that I would commit every time we had a schema change. And so what I did was I created that model that defined all of our tables and a couple of our views. And then for the views that had some complex dependencies and maybe depended on a type or something like that, I put those in a separate directory. I had some weird custom types and domains and things like that. I put that in another directory. And then all of the rest of our stored procedures, which are PLPG-SQL for the most part currently. There might be some PL Python in there as well. I put them in this procs directory. So I just have this little directory structure that I created, and then I wrote a function that loads those files from there. And you might ask, how do you deal with dependencies in here? Because there might be some view that depends on a stored procedure, or vice versa. And I hacked it in. I just used sorting by whatever the default sorting is. So I put like a 001 or something like that in a file that I know for sure that has to do that. I'm lucky I don't have a lot of dependencies between these raw SQL, whatever objects are being created by the raw SQL. If I did have a lot of dependencies, I would have come up with a more sophisticated system. But right now, it's just like 2 files that I had to rename. So anyway, so this is how I do it every time. And the advantage to having this all broken out this way is that now I can get code reviews on diffs of stored procedures, which was just not possible before. And this is the thing that makes me happiest of like everything else. You saw that cat before, like this is like a nyan cat, like it like is like a new level of happiness. But anyway, like I really struggled with this for a long time. How was I going to get the developers to actually look at diffs of stored procedures? And this is how I did it. Another thing that you might run into is needing to stamp a fresh database. This is how you do it. This is actually in the docs, so it's not that big of a deal, but just showing that this functionality is there, and it's very much appreciated. Use this for building test databases that the continuous integration runs against. So here's my lessons learned. One insight that I've had fairly recently, like I couldn't figure out for a long time, how was I going to make the downgrades really work without storing multiple copies of the change, So let's say I make a change to a stored procedure, and then I want to downgrade it. But how do I do that, right? Do you understand? Does that make sense, like why that's a problem? Because I've already committed the change, right? So the currently visible version of that stored procedure in my code base is the most recent one. And if I run the downgrade function to reload that file, it's just going to load the same file that's in the repo. Well, what I came to was if I commit the migration separately from all the rest of my code changes, I can keep the migration, but roll back the code change. So that if I run the migration downgrade again, and I've reverted a commit, then now it sees the old version of the SQL file. And this is how I'm going to do it. So it just really wasn't obvious to me how this was going to work until I was just using the system for a while, and I was like, oh, okay. So yeah, we still revert commits occasionally. So, something just didn't work out, some feature wasn't great, and now we'll revert that, but we'll keep the migration so we can downgrade the change in the database. The other lesson that I had was just storing the schema objects, just getting them into the smallest reasonable composable unit. Another thing that we really struggled with was like, how are we going to group all of the functions? How are we going to group functions together? And we just decided, 128 files, whatever. I'll just separate them all. They'll all be their own files and just accept that that's going to happen. We use the ORM for the core parts of the schema, the tables, some of the views. And I think in some cases, when you've got a schema that's operating at the center of a lot of different competing applications, you may actually want to store your schema in a separate revision-controlled repo. There are a couple people that suggested that, just so that you can maintain all of this without dealing with the release cycle of other applications that depend on it. And the last part is that tests have saved us so many times. I'd make a change in a stored procedure that affected some data, and because we had tests, I was able to detect in this other far-flung reach, of the application, we made a mistake. So we use no's and a lot of unit tests. We have some integration tests, and we actually have like some full system tests as well. So we're like, we got a lot of tests. But starting out with really simple things, like just something that creates the schema and tears it down, can be really effective in finding very simple errors. And then every time you make a mistake, every time something doesn't go quite right, write a test for that. We've gotten to be very disciplined about doing this, and again, it has saved so much time in the early stages. I make a schema change, run the test suite, finds the error right away. Another thing that we found that's like so obvious, right? But we didn't actually have a fake data generator. Again, it was being done separately in lots of different places, but there was no one central place where you could create a set of fake data for our entire schema. When we finally did that, again, caught so many bugs, found so many problems. I was able to make a one-character change to catch an error a large error in our aggregation system. And I don't know, it's just very, very helpful to have these tools. So since Mike's in the room, here's a few things that I wish Alembic did automatically. I wish that Alembic understood partitions and that I didn't have to give it a regular expression to figure that out. I have a couple ideas about how it might do this, but I wish that it understood that as part of the system natively. I wish that when I was creating a column, that it never tried to apply a default when it was creating that column. You guys are aware of this optimization? So when you're adding a new column to Postgres, it'll be like instantaneous as long as you don't specify a default. And then what you do is you do the alter table to add the column, and then you apply the default afterward. And that is the way that you don't lock your table forever. So it would be nice if Alembic understood that, because that's a pretty common DBA pattern. I wish that Alembic understood how to manage user-defined functions a little better. I've come up with a system that works okay for us, but I do think it could be a little better. I was having trouble even now, explaining it to you. I could tell some of you were looking at me like, I don't even know what she's talking about. But I wish that there was a better way to do this. And I don't mean that in a really Alembic criticism. Most systems actually don't handle UDFs very well. And if you have a system that you're using, you should tell me about it, because I'd love to hear how it works, because I really have seen almost nothing that handles this well. Another thing, how many of you here know about index concurrently? Yeah, most of you. There's a couple of you that don't. So when you're adding an index, use concurrently. Just add it to the statement. And what it does is it helps try not to impose so many locks when it's adding the index. And I wish that, again, that this was a default. It is. It is more expensive, but like, you know, yeah. Trade speed for convenience.
Is it not possible to end up with broken indexes using concurrently?
It is possible. Yes. Yep. Yes. So full disclosure, it's possible. In my experience, it's awesome. Concurrently is way better. But anyway, yeah, the last thing that I would say is I wish there was a prettier syntax for multi-commit sequences, because this is often something you have to do. Like in my case, I can't change all of the check constraints on 1,000 partitions all at the same time without having some commits in between there, or else I'm just going to like totally screw up my database. So it would just be nice if there was a better pattern for this. And I actually don't know exactly what that better pattern would really look like. I mean, basically what I do is I just, you know, I typically just put a commit manually in, and then at the end of each loop, you know, I issue another commit. But, you know, I wish there was a nicer way of doing that. But those are really, that's not too many bad complaints, I think. So like I said, I don't think any tool is going to be perfect, but things like Alembic will make your life way, way better. I really think that, you know, DBAs should be driving this because you're mostly going to be responsible for it if it breaks. And so you should get to choose the tool, right? And I also think that working with developers on choosing a tool and using a tool that works in the language that they're most comfortable in will lead to them actually spending the time to review your code, which I think is another really important best practice for schema changes. So yeah, so pick a tool that they like, or if they don't like anything, one that they at least don't totally hate. So there's some other tools that people have asked me about when I was doing research for this. People made a few different suggestions. Skitch, which is written by a Postgres contributor, David Wheeler. You can check that out. It's written in Perl. It actually looks like it has a lot of similar features to Alembic, so definitely if you want to have a look at something written by a Postgres contributor, have a look at that. Irwin, it's a commercial product, but Oracle DBAs recommended it, and they did say that it had a migration functionality built into it, which I thought was pretty interesting. That's a GUI tool. And then there's, of course, South, which is pretty famous and popular in the Django world. It is Django ORM specific, but it's pretty well supported, and again, probably worth looking at if you're using Django. For Alembic, there's always the source you can check out on Bitbucket, and that's Mike's repo. Read the docs page is really great. Excuse me, I'll show you on some water. And then finally, there's a great Google group. Mike does a really great job of answering questions right away. I hear he could use a little help, so if any of you, I'm going to go subscribe to mailing lists and start answering questions. You know, definitely subscribe to that. There's a lot of useful stuff in there. Definitely search it for answers to problems that you've had. I found so many answers to questions that I had in that group. And people, I've seen a few people writing blog posts about Alembic as well. I've written a few, but I think that Google group has probably got the most up-to-date stuff in it. Yeah, and so that's it. So how much time? Got a few minutes. So I can show you very quickly. Oops. I turned on left-hand mousing, which was probably a mistake. So in here, you know, we've got all this stuff in here. So I have an Alembic directory, and there's all our files. You can see in here my m.py. Sorry, that just looks terrible, but you know, here's my include symbol. And look at, I put comments in there even. I'm so good. So, you know, you edit your m.py. Let's see, where did I put my, I think I have in my config alembic.ini in there, which I think has my, hopefully, you know, little simple ini file configuration. And the main thing that I had to change, of course, was the SQL Alchemy URL, and that's pretty much it. And we just use that. And then in versions, That's where all your migrations live. I'm going to remove those so it's a little easier to see. So you can see there's a few in here, 26, it's not too bad. And I'll give you a look at these. They're kind of hard to look at right now because I've been including, I've kind of been lazy, and my template, what's the template called? Sorry. So there's a template, script.py.mako, that you can modify. And this template is what, is the basis for every migration. And in here, I dumped, well, this is my latest version. In here, I'm specifying like Cytex type and JSON type because I had some custom things that I was doing. But in these older migrations, you'll just see that I dumped the types like into the migration because I was being super lazy. But anyway, future migrations will be prettier. So, give you a look at what a version thing looks like. Sorry, I can type. I know how to use computers. So yeah, so here's what a revision looks like. You can see right there you got revision, that's this current revision number, and then down revision. I hope you notice that these are like non-monotonically increasing numbers. That's really nice. Like I skipped over that in my diagram, but it was so frustrating that previously we'd had our migrations tied to release versions, and so if the feature slipped, I have to go back and edit all these stupid files that had the release version hard-coded in them, and what a pain. Like, it was just horrible. So this is a really, really nice feature, and there's some features coming up that are going to make managing the revisions and down revisions a lot easier. And then you can see my boilerplate there, my, horrible types. This is what an upgrade looks like. So I'm creating a table called transform rules, and I'm adding some columns here. You'll notice there's no defaults specified, and I got a few, looks like some bulk inserting of things in here. That indexes thing is incorrect comment, but anyway, you can use bulk insert to put in data, which is nice, a little faster. And there's not very much data that I'm putting in there, but that's okay. And then down here, there's my downgrade, which just removes from transform rules a couple things that I didn't want in there. So anyway, so that's how all that works. Running Alembic itself, for us, is a little complicated because I have a terrible hybrid environment. But for me, I activate my virtual env. And then I tell it where my Python path is, which is right here. It's terrible, I'm sorry. And then I run Alembic. I give it my special configuration file, which is local, but you can specify this in a place. You can put your INI file in a place so you don't have to do that. And then you can do something like this and say what my current migration is. It's kind of hard to read, but it tells you. My latest migration is fix Android devices. You can look at the history. I'll give you all of that through there. That's hard to read again, but you can see it goes all the way back, and then in the end tells you you're at the head. It also knows some things like, so you do downgrade. You can do stuff like this, relative downgrades. You can do an upgrade, like that. And you can also say upgrade head, just upgrade everything to the most recent revision, and it'll do that. So yeah, any questions? Yes?
You mentioned a fake data generator. Is that your made, or are there tools that go onto that?
No, it's really bad. I don't feel bad about saying stuff like that anymore because all software is terrible. Okay, so I'll show you what ours looks like. It is homemade. This next quarter, I'm going to kind of look at this and rewrite it to use the model, first of all, because right now it's just kind of stuck in there. So, they did some stuff to get random things put in there, but yeah, it's not that great. But yeah, so basically what we did was we created this base set of definitions. Water wolf. Does that sound sort of like Firefox? And you know, we put all this base data in here, and then we just have some functions that generate data based on that base table, essentially. But yeah, we would like to use the ORM defined table for that in the future, so that it's easier, less code. But this thing is freaking awesome. Yeah, and now the developers just add stuff in here all the time, especially for reports. This was a huge problem before. Like, nobody knew how to test that our reports were correct, and so they would just kind of guess. And yeah, anyway, it's much better now. Yes?
So the idea with stored procedures is that you've only got one version of a stored procedure in a particular version of the code, and then if you want to downgrade, you have to check out this version of code first, then downgrade.
Yeah, so the way that our release process works is when we do a release, so in stage, we have a tool that checks every 15 minutes to see if there's an updated version of the code. And if there is, it grabs the bundle and just deploys it out to all of the systems. It's about 6 different machines get it. In prod, it's more like 40 systems or whatever. And so we have a sysadmin who does the push. And so when that happens, all of the systems get the new bundle at the same time. In the past, the database servers were exempt. But I think that that's actually wrong, like from a process standpoint. I think that the database server should be getting the same version of code as everything else. So, so if we were to revert something, what we would do is do a revert commit. And as long as the migration was outside of that, whatever it was that we reverted, that would work. So you revert the commit, and let's say I changed my stored procedure. Let's pick a good one. So in procs, I have update ADU. So let's say I changed this function, but I reverted it. So now when the new code gets pushed out, the migration will still be there, but a different version of update ADU will be present in the code that got pushed. So if I run the downgrade, then the new, the old version of the function will get loaded.
So migration files for that same stored procedure file?
Yes.
So, all right, so you update that SQL file.
Yes, I do.
Go over to the Alembic migration.
Yep.
And add a directive, run this guy.
Yep.
So you have a lot of those.
Yeah, so I just have like a loop. Show
But
you.
you give it specifics list of files you care about.
Yep.
So it's not right.
Yep, exactly.
And there's no problem with the fact that you have things that would be out of sync, like if you run an old migration,
Yep.
SQL file is actually this version. That's later on.
Right, yeah. So my assumption is that you're not doing something terrible, right?
But you couldn't just downgrade in place. I couldn't check out your code and say downgrade to this.
No, you're not going to be able to. Yeah, right. I treat the migration system as a production and stage tool. I do not treat it as, right, yeah, I don't treat it as a source of truth about what the schema should be at a point in time. Yeah, and that could be a flaw. We don't really need that as a feature. That's a good point, though.
You don't need downgrades at all.
No, we don't. Well, we do need downgrades for the situation where we make a mistake, for sure. But we don't need it from the perspective of change these stored procedures so that they fit a certain point in time. You can still check out a version of the code at a certain point in time, at a certain commit, and get the right thing. You will get the right thing at that certain point. But yeah, you don't have this like time travel capability because of what I've done.
How do you handle the changes? You make a change in a table which is going to affect the stored procedure or vice versa.
I have to know that, right? Or whoever is making the change has to know that. Because it's not really, I don't know how to interrogate the system in a way without writing a parser, right? Like, and I'm not going to do that. So it is up to the user to do the right thing. And then, when I have dependencies, I've handled it by either changing the order. So like I have my core set of things. So I have some views defined and all of my core schema elements defined in the model. And then we have some types that are only used in views or only used in a stored procedure. And so those get loaded after the model. So I do have like some kind of implicit things there, and then I have some very explicit, like I've numbered, I've added a number, to a certain stored procedure so that it gets loaded first. Like I said, my environment is fairly simple in that sense. Like I don't have that many dependencies, so I just handled it by renaming things. Any other questions? Well, thank you very much. You're a lovely audience. Please find me. I'll be here next day.